Hi everyone. In previous class we discussed about different types of ingredients to prepare semi-solids. Today we will discuss about methods of preparation. In this method of preparation we have different types of method. First one is saturation method, second one is fusion method, third one is emulsification method. In emulsification methods we have again four types. First one is preparation of oil and aqueous phases, second one is mixing of the phases, third one is cooling the emulsion, fourth one is homogenization, and final method is chemical reaction method. The first method is trituration method. Trituration method, it is the most commonly used for the preparation of semi-solid. This trituration method we are using for reducing substances to fine particles by rubbing or grinding them with a mortar and pestle or an ointment slab. If you see the flowchart, we can easily understand how to do this method. So first one is size reduction, and the next step is revocation and mixing with base. Next, spatulation or trituration. Next, mixing base to produce final weight, and next homogenization, and final step is filling. This size reduction commonly used in pharmaceutical industries because this size reduction increase the surface area in most reactions involving the solid particles. The rate of reactions is directly proportional to the area of contact with the second phase. So next, break a material into very small particles in order to separate the valuable amongst the two constituents. So achieve intimate mixing and to dispose solid wastes easily, to improve the handling characteristics, and finally to mix solid particles more intimately. So lavication means lavication is the process of reducing particle size of a solid by triturating it in a mortar or spatulating it on a ointment slab or pad with a small amount of liquid or melted base in which the solid is not soluble. They make incorporating solid easier, and they usually give smoother preparation. Homogenization means process of conversion of coarse emulsion into colloidal state of uniform composition. The next method is fusion method. The ingredients of the base are melted together and properly mixed to obtain a uniform product. On small scale, fusion method is carried out in a porcelain dish, which is placed in a water bath. Initially, the ingredient of high melting points is melted. Then remaining ingredient of the base are added in the decreasing order of their melting points and melted with constant stirring. The above mixture is removed from the water bath and stirred in order to cool it. If the drug is soluble in the base, then its powder from is added to the molten base. Liquid or semi-solid are added at a temperature of 40 degrees centigrade. Insoluble additives are added in small quantities with proper stirring. When the thickening when the thickening of the base starts, localized cooling of the molten base and vigorous stirring should be avoided to prevent aeration of the ointment. The next method is emulsification method. In this emulsification method, we have mainly four steps: preparation of oil and aqueous phases. Second step is mixing of the phases, and third step is cooling the emulsion, and fourth step is homogenization. The first step is Preparation of oil and aqueous phases. In these phases, the components of the oil mixtures are placed into stainless steel steam jacketed kettle, melted and mixed. Some of the solid components, example stearic acid, acetyl alcohol, are available in many different forms like cakes, flakes or powder. The flakes are more preferable because of the convenience of handling. Petrol atom is inconvenient to handle unless it is melted and transferred by pumping or pouring from its drum. The oil phase is then strained through several layers of cheesecloth to remove any foreign matter. If petrol atom is used as oil phase, then it should be passed through filter medium, particularly in ophthalmic preparations. The oil phase is transferred by gravity or pumped to the emulsion mixing kettle. The components of the aqueous phases are dissolved in the purified water and filtered. A soluble drug may be added to this aqueous phase. Next step is mixing of phases. The phases are usually mixed at a temperature of 70 to 72 degrees centigrade because at this temperature intimate mixing of liquid phases can occur. The properties of some emulsions depend on the temperature at which the phases are mixed. The initial mixing temperature must be raised above 70 to 72 degrees centigrade. We have three ways to mixing this phase. First one is simultaneous blending of the phases, and second way is addition of the discontinuous phase to the continuous phase, and third phase is addition of the continuous phase to the discontinuous phase. In this mixing of phases, the simultaneous blending of the phases requires the use of a uh, proportioning pump and continuous mixer. This method is used continuous or large batch operation. The second method is used for emulsion system that have a low volume of dispersed phase. The third process is preferred for many emulsion systems. In this mixing of phases, we are using some equipments. For example, agitator mixer. In agitator mixer, we are using sigma mixer and planetary mixer. Next one is shear mixer. In this shear mixers, we are using triple roller mill and colloidal mill. Sigma blade mixer. The mechanism of mixing is shearing. The sigma shaped blades creates high shear. Advantages are it creates a minimum dead space during mixing. It is used for wet granulation process. Disadvantages are it works at a fixed speed. Next equipment is colloidal mill. It consists of two steel discs. Here one disc rotates and another one is stationary. When the material is passed through the disc, they get sheared. Thus, coarse particles are break down to small particles due to the shear. Advantages are it can be used in production of sterile products, and disadvantages are it is not used for dry milling and heat is generated during milling. Next, cooling the emulsion. The rate of cooling is generally slow to allow for adequate mixing while the emulsion is still liquid. The temperature of the cooling medium in the equipment should be decreased gradually and at a rate constant with the mixing of the emulsion and scraping of the kettle walls to prevent formation of congealed masses of the ointment or cream. Perfume should be added at 43 to 45 degrees centigrade to avoid chilling the emulsion in case of oil in water type emulsion. Perfume should be added at room temperature in water in oil type emulsions. If the drug is not added in the aqueous phase, then it should be added in solution form or in the form of crystals. Finally, homogenization. The creams or ointments that require further treatment are then transferred to the proper homogenizer, the selection of which is governed by the degree and rate of shear stress required. The choice include a low shear gear pump, roller mill, a colloidal mill, a valve type homogenizer. Next, chemical reaction method. In this product is formed by chemical reaction which involves both fusion and mechanical mixing. Best example of this method is iodine ointment. Procedure is powder iodine in a mortar and pestle and add arachis oil taken in a flask Heat the mixture to 50 degrees centigrade with occasional stirring until greenish black color appears, and yellow soft paraffin to the above mixture and heat it to 40 degrees centigrade with mixing. Cool the ointment. In next class, we will discuss about a clear gels manufacturing procedure and evaluation and packaging. Thank you.